Hello, grade 10. This is our 7th online lecture. And in this lecture, I'm going to explain a new lesson, which is the absolute value and intervals. In this lecture, we are going to identify the absolute value of a real number. We are going to use the properties of the absolute value. We are going to use the absolute value to calculate the distance between 2 points on the axis, and use the intervals to find their midpoint, radius, and length. Actually, this lesson I'm going to split it into 2 parts. I'm going to start first by the first 2 objectives, and hopefully next week I'm going to continue the others. So first of all, we are going to talk about the absolute value. And in mathematics, the absolute value or modulus of a real number is denoted, as you can see. It's between two dashes like this, as you can see it. That means the absolute value, and it's the non-negative value of x without regard to its sign. So whatever you have inside the absolute, its answer, it should be a positive value. So if you can see in the second case, we have absolute value of x. It's equal to minus x if x is negative. Just in case x is negative, you can write this, because negative and negative, they give you a positive value. So first of all, you should keep in mind that the answer of the absolute value, it's always positive. The contents of our lesson is to find the distance between two real numbers. We are going to take the properties of absolute value, and we are going to talk about midpoint, length, and radius. But before we start, I need to make a quick revision for something that I need in this video. First of all, what's the meaning of evaluating and simplifying expressions? First, an expression, it's a math statement without an equal sign. So any expression, for example, 2x plus 3, this is an expression. It contains variables. It contains constant without an equal sign. Evaluate, it's to test a value for a variable. So you should replace a variable with a constant using pandas and substitution and so on. Simplifying means it's to complete all order of operations and properties in an expression. And when I say an equation, it means a math statement with an equal sign. You need to solve in order to find the variable. Inequality, it means it has an inequality sign greater than or equal, less than, and so on. And now I'm going to remind you, how do we solve a linear equation and inequality. So first I'm going to start by solving a linear equation. The first thing you have to do is to simplify both of equations, both sides. So if you have, for example, parentheses, you should expand. So that's why we say you should simplify first. Then you have to move the variable to one side. So the variables to one side and the constants to the other side. And then we are going to use inverse operations. So if, for example, if you have a number and you need to take it to another side, if it's positive, you have to change it into negative and you take it to the opposite side. So the addition, if you move it to the other side, it becomes subtraction. And if you have multiplication, you take it to the other side as division. And if you have a square root, you have to square in order to get rid of the square root. And in inequalities, you have to take this into consideration, that if you divide or multiply both sides by a negative value, you have to switch the inequality. So if it's a positive or it's greater than, it becomes less than. We are going to practice this later on. So let us first start by solving these equations. So if you look at the first one, we have 2 over 3d equals 5. This is very easy. You just put 5 over 1 and you do the cross multiplication. So you multiply 2d by 1 equals 3 times 5. So you get 2d equals 15. And then I need to find the value of d, so it's 15 over 2. In the second one, as you can see, the first thing you have to do is to expand. Okay, so simplify, you will get 6x minus 14 plus 9 equals 25. The second step is to take the variables to a side and the constants to another side. So you will get 6x minus 5 equals 25, then 6x equals 30. And now you find the value of x, which is 30 over 6 equals 5. In the third one, also you have to take the variables to a side and the constants to the other side. So minus 10w minus 6w equals 2 minus 34, and minus 16w equals minus 32, so w equals 2. In the last one, as you can see, you have to take the variables that contains the y into a side and the constant to the other side, and then you do the common denominator, and then you do the cross multiplication, and you find the value of y. Now, in inequalities. So when solving inequalities, the same rules apply for the equations, except when you multiply or divide by a negative number, you have to flip the sign. This symbol is less than, greater than. This is less than or equal. This is greater than or equal. And in graphing, if you don't have or equal, you put an open circle, while if you have an equal, you do the closed circle, as you can see. As an example, let us solve the first one. So first of all, you have to simplify. You multiply the minus 4 by x and the minus 4 by 1. So you will get minus 4x minus 1 greater than 21. The same steps for equations. You have to put the variables to a side and the constant to the other side. So you will get minus 4x greater than 22. In this case, you need to multiply by minus. Why? Because I have to get rid of this minus beside the x. So whenever you multiply by minus, don't forget that you have to flip the sign. So it becomes, as you can see, 4x is less than minus 22, and then you continue normally, you will get x less than minus 22 over 4. In the second one, we have 15 minus 5t greater than or equal to 55. So minus 5t is greater than 40. And here also you have to multiply by minus. So whenever you multiply by minus to get rid of the minus beside the t, you should keep in mind that you have to flip the sign. So it's greater than or equal, so it becomes less than or equal. And whenever you multiply the 40 by minus, you will get minus 40. So it will be like this. And then you continue, t is less than or equal to minus 40 over 5, which is minus 8. In the third one also, we bring the variables to a side and the constant to a side. You will get minus 8x greater than minus 24. So you don't get rid of the minus and that's it. No, you have to flip the sign. So it becomes 8x less than or equal to 24, then x is less than or equal to 3. In the last one, you can do also the cross multiplication. So it becomes 3x plus 24 greater than 4x. You bring the variables to a side. So now I have minus x greater than minus 24. Then x is less than 24 because you need to multiply all this inequality by minus. And don't forget to flip the sign. So if it's greater than, it becomes less than. So that was a revision of how do you solve an equation and inequation, because I needed starting from now on. So going back to our lesson, we are going to explain something new, which is the absolute value. And we said the absolute value, it's represented by the two dashes, as you can see, and it's always equal to a positive number only. Okay, so let us start. So the absolute value of a real number, it's the distance between x and O in the axis of abscissa. So if you have absolute value of x for x greater than or equal to 0, minus x for x less than 0. What does that mean? So for any real number, absolute value of x it's always positive, as we said, and absolute value of minus x is equal to absolute value of x, because in both cases you are going to get the positive value of the number. And absolute value of x equals to 0, it's only when x itself it's 0. And of course, x is always less than its absolute or equal, because sometimes x could be a negative number. So inside the absolute, it might be a negative number, but its absolute, it's always positive. And radical x squared, it's equal exactly to the absolute of x. Example, let us take an example. So let us look at the first one. Absolute value of 5, it's 5. But the absolute value of minus 5, it's 5. So you take it as a positive value. So everything inside the absolute should be a positive value. So what's the absolute of minus 14.4? It's 14.4. So it's a positive value. Now, 1 minus radical 3, you have to check if this number is positive or negative. If it's positive, then you put it as it is. But if it's negative, you have to flip it. So it's radical 3 minus 1, because maybe, for example, if you put it 1 minus radical 3 as it is, this is a negative number, so it's impossible to take the number outside the absolute as negative. So you have to check. If it's positive, then you put it as it is. If it is negative, you flip it. Just an example. Suppose you have radical 7 minus 3 or minus 2. Okay, radical 7 minus 2 or minus 1. I know that radical 7 minus 1, it's definitely a positive number. So the absolute of this number is radical 7 minus 1. Okay, so, but if it's negative number, you have to flip it. Okay, suppose I have radical 5 minus 10. This is a negative number. So I take it 10 minus radical 5. Okay? So what if I have absolute x minus 2 and I don't know anything about x? It's any real number. So absolute x minus 2, it's x minus 2 if x is greater than 2, because in this case you will get a positive value. It's equal to 0 if by chance x equals 2, then the answer will be 0. And if x is less than 2, you have to flip it, as you can see. So this is the general one. If you have numbers that you don't have their exact value, you have to take the three conditions. And now radical minus 5 squared, it's the same as absolute value of minus 5, which is 5, because the square here will get rid of the minus because it's an even number. Now, what's the distance between two real numbers? Actually, the distance is the difference between the two real numbers. But if A is greater than B, then the difference will be A minus B. But if A is less than B, you have to flip this formula, as you can see. For an example, look at this. The distance from A to O. From A to O. We don't say that the distance is minus 3. It's actually the distance is 3, for example, centimeters to the left. But we write the distance in its positive value, which is 3. That's why the distance is related to the absolute value. But the distance from A to B, if you can see here, it's 7. Okay? So the distance is 3 minus 4. So it's absolute value of 7, which is 7. So the distance should be positive value. So the absolute value, it's a positive value. Now, suppose I have a point M. I don't know where it's located, but what I know is that the distance from A to M, it's x minus 3. So, if x is greater than 3, then the distance is x minus 3. If x is equal to 3, then M is confounded on 0. But if x is less than 3, you have to flip it like this. Now, some properties of the absolute value. If A is greater, this is already known. So if A is greater than B, then the absolute of A minus B is A minus B. If A is less than B, then the absolute of A minus B, you flip it. And we already learned that radical A squared is the same as absolute A. And we learned that A is less than its absolute. Absolute X is all of these. We already take them. So let us, just the new properties is that if you if you split the absolute, you can do it like this. So if they are multiplied inside the absolute, you can split them into two absolutes. And the absolute of a fraction, it's the absolute of the numerator over the absolute of the denominator. And absolute x plus y, it's always less than the absolute of their addition. And absolute x minus y, it's always less than the absolute of their subtraction. Sorry, this should be subtraction. Let us take the example of every one of them. So we have absolute 7 minus 5. It's the same as absolute 5 minus 7 because in both cases we are going to have 2 as an answer, because here the absolute of 2 is 2 and the absolute of minus 2 is 2. And if you have their multiplication, you can let us do the first one. So it's absolute of minus 6, which is 6. And also if you split the two absolutes, you will get the same answer, which is 6. So they are equal. Also, if you split the fraction, the absolute for the numerator and the denominator, you are going to get the same answer. And here, if you do absolute of x plus y, you are going to get 3. And if you split the absolute for the addition, you are going to get 13. So we can say this is related to this one. So the absolute of their addition is less than the addition of every absolute alone, as you can see. Okay? And now 5 plus 8, absolute 5 plus 8 is 13. So absolute of 13 is 13. And if you subtract them, absolute of 5 minus absolute of A, it's equal to minus 3. So the absolute of their addition is greater than the absolute of their subtraction. Those are some properties that you might use when solving. Now, use the absolute value to calculate the distance between 2 points on an axis. This is very important. So, if you have 2 points, minus r and r, absolute x equals r. So if I tell you that absolute x equals r, this position, it could be on minus r or in r, because in both cases the distance, it's positive. So what I'm trying to tell you is that the position of x is on 3. So x, it could be on 3 or on minus 3. So I need to take this in consideration when I'm solving. So whenever you solve an equation, you have to take it first time positive and the second time negative. Because as I told you, suppose I have absolute A equals 5. How can I know that A, for example, it's on plus 5 or on minus 5? We said that the absolute, it's the distance. So it could be the distance from 0 to 5 or from 0 to minus 5, because both of them will give me the distance as 5. So I need to take the two conditions. Let us start exercises to understand what I'm trying to say. I'm going to start by the first one. Here we have absolute 3 minus 2x plus 5 equals 9. Keep in mind that you have to keep the absolute on one side by itself. So you have to isolate the absolute alone. So I need to take the plus 5 to the other side. So it becomes absolute 3 minus 2x equals 4, because 9 minus 5 equals 4. As I told you, you have to take two cases. The first time I'm going to take 3 minus 2x. equals to 4, or 3 minus 2x equals to minus 4. And now you know how to solve these equations. You have to put the variables to a side and the constant to the other side. So minus 2x equals 1, then x equals minus half. And now to solve the second one, minus 2x equals minus 7, then x equals 7 over 2. So the solution of this absolute value is minus half and 7 over 2. So it's very easy. There are only 3 steps. First, isolate, keep the absolute alone by itself on a side. Then take 2 cases. So the first time we take 4 and the second time we take minus 4. So the first time you take it positive, the second time you take it negative. And the third step you have to solve, as I taught you in the beginning of the video. Another example, we have 3k minus 1 minus 4 equals to 6. So the first step is to isolate, or in another word, to keep the absolute by itself. So absolute 3x minus 1 equals 10. Then, now in this case, I'm going to take 2 cases. The first case, I take it as it is, 3k minus 1 equals 10. And the second case, 3k minus 1 equals minus 10. And I solve normally, as I taught you in solving the equation. So 3k equals 11, k equals 11 over 3. 3k equals minus 9, k equals minus 3. So the set of the solution is minus 3 and 11 over 3. Let us continue also for another example. As I told you, you isolate the absolute alone by itself. Then this is no solution because it's impossible to find an absolute value equals to negative number. Pay attention. Okay? Don't fall in this trick. The third case, if I have the absolute equals to 0, then actually I have only one condition where I take 2y plus 5 equals to 0, then 2y, y equals minus 5 over 2, because I can't put it 2y plus 5 equals minus 0. Okay, so the only solution is minus 5 over 2. So till now we have learned that if I have the absolute value equals to a number, we take it the first time equals to a positive and the second time equals to a negative. If it's equal to 0, I take only one condition. Now what if I have absolute value equations with 2 absolute values? So an absolute value is equal to an absolute value. So it's the same steps. I'm going to take 2w plus 4, which is the first absolute, equals 3w minus 2, the same. And in the second case, I'm going to take its opposite. Okay, so I continue the variables to a side and the constant to the other side. So, and we solve, then the set of solution is minus 2 over 5 and 6. Okay, let us take another example. So if you have 2 absolute values, you take the first one equal to the second one as they are. This is the same case. And in the second case, you have to take its opposite. So we do minus into 3x plus 3. And we solve both of them normally. And then you will get k equals minus half. And then the second one, k equals minus 5 over 4. So the set is minus 5 over 4 and minus half. So that was everything in our lesson. It's just how to solve an absolute value. So keep in mind that we have 3 cases, or actually 4 cases. If an absolute value equals to a number, you take it the first time the same, the second time the opposite. If it's equal to a negative number, then it's no solution, it's impossible. If it's equal to 0, then you take it only a case equal to 0, you solve it normally. And if you have an absolute equals to an absolute, in the first case you take it the same, and in the second case you find its opposite. So I wish you understand everything in this lecture. Hopefully next week I'm going to continue when we have an absolute value with an inequality. What do we do? Okay?